Welcome to another edition of Danger DIY, where we're going to build a metal lathe with CNC controls. So we're going to be using all this material that I've ordered, including the cut steel, as well as some aluminum, and the tools you see laid out here. I ordered some linear rails as well as some screw drives, and I'm going to use a CNC kit that I'm going to build up, as well as using the NEMA 23 stepper high torque motors. But as you can see here, we'll see how everything works out using the tools I've got. So just kind of mocking it up here a little bit without actually doing any of the actual fabrication. This is the basic outline of what the sled of the CNC machine is going to look like. So I'm going to need to weld all this up. I'm going to need to measure it out, and then I'm going to need to go ahead and mark where the holes are going to go. So I'm just going to double check with the ruler here to make sure I've got a 1/4 inch on each side, and then I'm going to get the holes marked up and start some drilling, and go ahead and weld some pieces together as well. I'm not going to record the welding since I'm doing this by myself. I don't have an extra set of hands here to help me take photos or video this, so I apologize in advance for that. But let's go ahead and get started on some of the construction. So we got all the holes marked, and so let's go ahead and start to drill them through so we can mount the linear rails on. All right, well, that's one rail down and attached. Let's go ahead and get everything else attached and see how this sled works. So here we've got everything attached up, and the sled moves back and forth just fine. I've attached the top of this to the bottom using bolts. I can always come back and weld it later if it doesn't work out well, but I just use bolts. Everything below it's welded. So here I've welded on a long side plate, and this is where the screw drive is going to attach later on. So here I'm just measuring everything out, and I've got some magnetic holders that I've put in place with a piece of steel just to see where the sled movement's going to be at. You can see the line where the headstock is going to go, and so just testing that out here before I end up making any permanent changes to the metal. So it looks like this is going to work out just fine. Let's go ahead and start on the back plate and drill a hole on center.
That's a 3/4 inch drill bit going through a annealed steel plate, so I'm not sure this plate is exactly round, but that's the closest center I could find using a compass and a couple of other tools, measuring it, and then basically just picking one of the centers that I was able to find there. So this one I think is the closest. And then once I get it onto the lathe, I'll actually use the lathe to round it out so it's completely round. Oh hey, I just wanted to go over one more thing. You can't really tell because it's video, but the drill bit's only running at about 200 and something RPM, so, or maybe it's 400, I can't remember. This is the lowest setting for this drill press. And like I said, I'm not an expert machinist or anything, but I was always told to run high-speed steel slow and deliberate. And you can see over here on the dial here, it's feeding. Oops, I didn't turn it off. It is feeding very slowly. So I started at 1, and you see here I'm almost at a half. And this is half-inch material, so I'm almost through it. Probably in about another 30-40 seconds or so. Just to show you all the belt configuration. So And so it was at 220 is that top setting there, and that's where I put the belts. As you can see, what just happened, the bottom belt stopped, so the bit seized up, and that happens from time to time. And when it does, you just release the tension. So here it is done. I sure hope that is center. It looks like it, but we'll find out when we put it all together.
So I've got the rod welded to the plate and used a 90-degree square to make sure that it was all straight and ready to go. So it looks pretty good. Let's go ahead and continue on with the build and see what we end up with.
So I've assembled the headstock. It's tapped in with four 3/8 inch bolts. Hopefully that's sufficient. The headstock's attached to here with the same four 3/8 inch bolts that have been tapped into this 12-inch piece of rectangular steel tubing.
So here we're just designing the part that's going to come down and support the screw drive and allow it to move back and forth. And so let's go ahead and get that started. So just got it set up here in the vise where I've already drilled some of the holes, and then we're going to tap them as well to make sure that we can attach that extra piece. So this is literally just going to go on the end of the piece that's currently there. I'm going to basically bolt it in to the end piece there and then use that to extend out the additional piece. So we'll see how this works out here in just a bit. So that all worked out great. As you can see, attached to the screw drive. I did have to add a little shim to the end of it just to line everything up. And so I'll go back and make sure that that's all reinforced well and operating smoothly. But overall worked great, and looks like this is going to be able to work just fine. Let's go ahead and try a little demo. As you can see, the operation is smooth. It's moving back and forth. I'm using the screwdriver here to move it. Later on, we'll hook up the NEMA 23 high torque motor. So now that we got all that started up, why don't we go ahead and start working on the cross slide and getting the stuff prepped for that. So originally when I designed the sled, I made it too short. I didn't put enough room in there to add the cross slide. So we're going to drill some holes, tap them, and add in an extension. And here I'm just making sure the rail is going to fit and that these screws aren't going to interfere with its installation. And it doesn't look like they're going to interfere, so let's keep on with the build. So let's get the holes marked for the extension, and then let's move on to getting them drilled. So you can't tell from the video, but I just sliced my thumb with the angle grinder on the sanding paper that's on there. So just a quick reminder, always wear your gloves. I'm about to put mine on.
Nice and shiny. It looks like everything lines up. Hopefully it does, because I do not like it when they don't line up. So I had to extend this out when I was looking at the design of the railing over here and being able to get my tool post further out from my wheel. I looked at some other designs and they had the cross slide extending out quite a bit, and so I could have just done this with using a longer piece of aluminum to start with, which is what I should have done. But now that I've used this aluminum up, I didn't want to get a new sheet. I don't know how much it costs locally, but it cost me $50 for the 2 sheets I had shipped that are 1/4 inch. And so what I did is I repurposed what I had, and then I had some aluminum bar that I had to use anyway to shim
The linear rail because it wasn't the same height as the screw drive in the kit that I bought. But this is a really sturdy add-on. I don't think I'll have any problems with it. So here I'm just tapping out the holes for the linear rail. So just using a drill for that. I've had pretty good luck with it rather than using the manual tapping. I have broken a few, so just be careful if you do decide to do that. So by doing it this way, it just lets me screw the linear rails directly into this, which is very handy actually. As it ends up, I'm actually going to need to take this off, and I might have to shim it up with a washer or two so that it lines up with the screw drive. Now, when I first start off, I use a different piece of metal for the cross slide than I end up with. I end up putting together 2 6x6 pieces that I welded, and you end up using that as a cross slide. Later on, I move it to a different sheet that's longer and skinnier, which you'll see in the final build. So let's just change gears a bit, and let's actually start to work on the electronics for the CNC machine. So what I've got here is the electronics part and the enclosure that I've built for it.
So this is the CNC controller. I picked this up at Amazon. This is just a little power board. I put a piece of Kydex on top of it just to insulate it in case, because this is going to rest up on top of it. And then these are the 2 stepper motor drivers here. I ended up going with the NEMA 23 high torque, and then I'm adding a fan here to keep it all cool. Anyway, it looks kind of a mess in here. I haven't bolted everything down, but rest assured it will be nice when I'm done. Made this on my press brake. Had to cut this away because I needed the space for this card to go out the side here because it has to be accessible. And the cover plate has a hole in it for that. Anyway, that's it for this part of it. I'm going to attach the stepper motors with these connectors and add the other set to it. Stepper motor are black and green for A, red and blue for B. So black and green are A and red and blue are B. And there's corresponding areas on the stepper drivers that you put them on. These are pretty nice stepper drivers for the motors, and they basically pretty easy to set up and everything. There's lots of videos on this, so I'm not going to go over it. But can be a little tricky, but it's once you figure it out, it's super easy actually. And I was able to do that. And I just ordered an old computer to hook up with a legacy parallel port for $100, and that's what I'm going to use to drive this system.
So good news, bad news. I did a little bit of work off video. So I've got all of the cross slide done and the tool post mounted. And I've installed the NEMA 23 motor and I'm just running it through a quick couple cycles. And then we'll get to shaping that back plate so that I can drill it and get the chuck put on. Let's go ahead and see what we can do. So as you can see, the CNC lathe with the motors and the controller hooked up are pretty much done. And I'm running an autonomous job just to shape the back plate, which has a lot of work left to go on it. I need to make it exactly the right size for the chuck. So that's what I'm working on right here. And let's go ahead and watch this at a faster speed until we get the chuck put on. So yay, this backplate is exactly the size it needs to be. And so I've removed the spindle from the pillow bearings and I'm bringing those out to the drill press and going to measure up the holes and get them drilled and get the chuck attached. So that's one hole down, two to go, and then let's get the chuck attached to the backplate. So I got the chuck attached to the back plate, and now I just need to tighten everything up, and let's give it a spin.
Let's hope nothing flies off and hurts me. So we're just going to turn it on, and I'm going to start off on low RPM. Ooh, low RPM. And then we'll speed it up a little bit.
So this looks like it's working great. So let's go and get some round bar in here and see what we're able to do.
All right, well, I got the bolts, got it bolted down now. See right here, and over here as well. And testing just facing this piece of aluminum. And so, the shallow pass here. Not the chatter still. Definitely do something to the headstock. Anyway, thanks for watching. I hope you liked the video. If you did, please give it a thumbs up and subscribe. And my next project from here is going to be a CNC plasma table. I'm going to use a lot of the lessons I learned here to try to improve that. But overall, this is a success for me. And it's a homemade CNC lathe and metal lathe. And just need to beef up the headstock a little bit and I'll be good to go. Well, I hope you enjoyed the video and you are able to get something out of it. Please leave some comments below and let me know what you thought. If you had questions, suggestions on how to do something better. I'm still learning and absolutely open to any type of comments. If you, I'll try to leave as many links as I can, but if I forget something, just ask and I'll add it to anything that you want to know more about. And I didn't go into much about the electronic wiring, but if you need to know more about that, just let me know and I'll be happy to send you some information on it. Anyway, I appreciate you taking the time to watch the video. Please like and subscribe And next project I have coming up is going to be some pool automation as well as a CNC plasma cutter. So I hope all that goes well. And thanks for joining me on Danger DIY.